Imagine a world where the very foundation of our digital security crumbles overnight. All your online bank accounts, classified military communications, and encrypted personal data suddenly readable, not because someone found your password, but because a revolutionary kind of computer made every current encryption method obsolete. This isn't a sci-fi movie plot. This is the very real and fast-approaching future of quantum computing. And it holds massive implications for national security. So what exactly is quantum computing? And why is it causing such a stir in the world of cybersecurity and defense? To understand that, we first need to break free from the world we know where. Classical computers rule. Traditional computers, like the one you're watching this on, process information using bits, ones, and zeros. These bits are the basic building blocks of computation in every task. Whether it's streaming a video or running missile defense software, boils down to manipulating long strings of these ones and zeros. But as powerful as our current computers, they operate linearly. If you want to crack a complex encryption key, a classical computer has to try every possible combination, one at a time. That could take thousands or even millions of years for truly strong encryption. Quantum computers. On the other hand, don't play by these rules. They operate using qubits, which, thanks to the strange principles of quantum mechanics, can exist as both a 1 and a 0 at the same time. This property is known as superposition, but the real magic happens when you add another principal entanglement. When qubits are entangled, changing the state of one instantly affects the other, no matter the distance between them. Together, superposition and entanglement allow quantum computers to process vast amounts of data simultaneously, enabling them to solve certain problems exponentially faster than classical computers ever could. Now imagine applying this capability to break encryption, most modern encryption, including the RSA algorithm used to protect everything from your credit card number to nuclear command codes. It relies on the fact that factoring large numbers is incredibly hard for classical computers. But a sufficiently powerful quantum computer could use something called Shor's algorithm, a quantum procedure developed in 1994 to break this encryption in mere seconds. What would have taken a classical supercomputer millions of years could be solved in a blink by a quantum machine. That's why some experts call quantum computing the Y2K of national security. Except this time, it's not just a glitch. It's a fundamental rewriting of what's considered safe. Governments around the world are paying attention. The United States, China, Russia, and members of the European Union are pouring billions into quantum research, not just for the sake of innovation, but out of a race to achieve quantum supremacy. The moment when a quantum computer outperforms a classical computer on a meaningful task. In 2019, Google announced it had achieved this milestone with a 53-qubit processor that solved a problem in 200 seconds. That would have taken the most powerful classical computer 10,000 years. Although the specific problem wasn't directly useful, the implications were clear. We are no longer theorizing about what quantum might do. We're witnessing its early stages in real time. But here's where things get even more urgent. While the hardware race continues, the threat to national security is not waiting. Cybersecurity experts warn of what's known as harvest now, decrypt later attacks. This is where adversaries, be they state-sponsored hackers or cybercriminal groups, intercept and store encrypted data today, knowing that in a few years, quantum computers may be able to crack it. That includes military secrets, medical records, diplomatic communications, and trade data. In short, we could be sitting on a ticking time bomb of exposed information. The National Institute of Standards and Technology, NIST, in the United States has recognized this risk and is actively working on developing quantum-resistant algorithms, what's known as post-quantum cryptography. These are encryption methods designed to withstand attacks from both classical and quantum computers. In 2022, NIST announced the first group of algorithms selected for standardization, signaling a critical first step towards securing the future of communication. But adoption takes time. Retrofitting existing infrastructure with these new cryptographic standards is a daunting and expensive task. Meanwhile, China is making enormous strides in quantum communication, which is an entirely different field, but equally significant for national security. Unlike regular encrypted communication, which can be intercepted, quantum communication can leverage the principles of quantum key distribution (QKD). This method allows two parties to share encryption keys in such a way that any attempt to intercept or eavesdrop is instantly detectable. In 2016, China launched MISIS, the world's first quantum satellite, and successfully demonstrated secure quantum communication between Beijing and Vienna. This gives them a potential strategic advantage, not just in securing their own communications, but in developing new global standards that might one day replace existing internet protocols. The growing quantum arms race isn't only about who builds the biggest machine. It's about who controls the rules of digital warfare in the 21st century. And unlike the Cold War, where the threat was visibly nuclear and physically destructive, the threat today is invisible, woven into the very fabric of our digital systems, infrastructure, and communications. As we delve deeper into this quantum revolution, it's crucial to understand that the impact of quantum computing on national security extends far beyond just encryption. It affects intelligence gathering, cybersecurity, infrastructure, military strategy, economic power, and even the very definition of technological dominance in a multipolar world. And while encryption is the most immediate and tangible threat, the real story is much broader and potentially more destabilizing. Let's begin with intelligence and espionage. Quantum computing has the potential to supercharge data analysis, making intelligence agencies far more efficient at processing massive volumes of information. Today's intelligence networks already collect vast amounts of data, everything from intercepted emails and social media chatter to satellite imagery and financial transactions. The challenge has never been the shortage of data, but the ability to filter through it quickly and accurately. Quantum algorithms like Grover's algorithm could potentially search through unsorted databases, quadratically faster than classical ones. That means intelligence agencies might be able to find connections or threats in hours instead of days or weeks. Enemy troop movements, terror plots, cyber intrusions all could be detected faster and more reliably, giving whoever owns quantum superiority a significant edge. Then there's quantum simulation, another powerful capability that may redefine defense technologies. Traditional simulations, such as those used in nuclear testing or drug development, are extremely complex and resource-heavy. Quantum computers, however, are uniquely suited for simulating quantum systems themselves, like atomic reactions or molecular structures. For national security, this could mean developing advanced materials for stealth technology, new chemical agents, or even more powerful explosives without the need for real-world testing. In fact, quantum simulation might become the backbone of future defense research, allowing countries to explore technologies that are currently unimaginable due to classical computational limits. But here's the twist. Quantum computing doesn't just empower defenders. It also arms attackers in unprecedented ways. For instance, quantum-enhanced hacking techniques could allow adversaries to break into previously secure systems, bypass detection algorithms, or forge digital signatures with frightening accuracy. Cybersecurity is already a cat-and-mouse game, and quantum will drastically tip the balance in favor of those with access to these tools. It's not just about defense against quantum attacks. It's also about preventing offensive quantum use by rival states or rogue actors. One emerging concern is the integration of quantum AI using quantum computing to enhance artificial intelligence models. Imagine combining the decision-making speed of advanced AI with the processing power of quantum computers. This could lead to real-time battlefield analytics, autonomous weapons that respond faster than any human could, or AI systems capable of planning multi-layered cyber attacks. Experts warn that this convergence could open Pandora's box, machines that not only outthink, but outstrategize. Human operators in conflict zones. This leads us into the growing debate over international regulation. Much like nuclear weapons, in the mid-20th century, quantum computing now poses a dual-use dilemma. It can be a force for incredible good solving climate models, accelerating medical breakthroughs, proving logistics, but it can also be a tool of overwhelming dominance. Should there be a Geneva Convention for quantum technology? Should countries establish a quantum non-proliferation treaty? These questions are already being debated in academic and policy circles. But there is no consensus and, more importantly, no global enforcement body for emerging tech like this. Adding another layer of complexity is the rise of quantum-enabled cyber warfare. In the future, a hostile nation-state could use quantum computers to disable critical infrastructure, not just communications and banking, but power grids, water, treatment plants, air traffic control, and defense systems. The idea of a quantum Pearl Harbor is now taken seriously by military analysts. A surprise cyber-attack using quantum tools that paralyzes a nation's digital infrastructure before a physical conflict even begins. In this high-stakes environment, nations are already adapting their strategies. The U.S. Department of Defense has launched the Quantify program to assess quantum threats and implement countermeasures across its agencies. NATO has established a Quantum Technologies Initiative to integrate quantum into allied defense frameworks. China, meanwhile, continues to make quantum research a centerpiece of its long-term defense doctrine, blending government-led research with private sector collaboration at an unprecedented scale. The race is not just about building quantum hardware, it's about securing quantum talent, supply chains, patents. One of the most overlooked aspects of this quantum arms race is the human factor. As more countries invest in quantum education and research, the talent gap becomes a national asset or liability. China reportedly graduates tens of thousands of quantum engineers every year. The US and Europe are ramping up their investments in quantum education, but they face challenges in retaining top researchers, many of whom are lured by lucrative offers from private tech firms or foreign governments. Whoever controls the talent pipeline may control the future. There's also a digital trust issue brewing beneath the surface. If citizens lose confidence in the security of online communication, financial systems, and digital identity due to quantum-enabled breaches, the social contract between governments and the people may erode. Public confidence in elections, banking, health records, and national defense hinges on digital integrity. Quantum threats strike at the heart of this trust. So, where does all of this lead us? If the trajectory continues as experts predict, the next decade will usher in a new era, one defined not just by who has the most powerful quantum computers, but by who uses them most strategically. The implications stretch across national borders, military doctrines, and societal structures. Quantum computing isn't just another technological wave like cloud computing or 5G. It's a seismic shift in capability. Global balance of power, Now let's shift our lens to how countries are preparing for this tectonic shift. The United States has launched the National Quantum Initiative Act, a coordinated government effort involving agencies like NIST, the Department of Energy, and the National Science Foundation. The goal is to build a quantum ecosystem supporting research, workforce development, and partnerships with private industry. This effort includes quantum encryption pilot programs with national laboratories and defense contractors already exploring secure communications networks that could one day be quantum-proof. Europe has taken a slightly different but equally ambitious approach. The European Union's quantum flagship is a 10-year billion-euro initiative aimed at positioning Europe as a global quantum leader. Their focus includes not only computing, but quantum sensing and communication as well. France and the Netherlands are investing heavily in national quantum labs, while also emphasizing cross-border collaboration to avoid fragmented development. China, meanwhile, is arguably the most aggressive player in the quantum field. Its strategy is centralized, long-term, and state-driven. Reports suggest that China has invested more than $10 billion in its national laboratory for quantum information sciences. And it's not just about research, it's about deployment. From the launch of the MISHA satellite to the development of quantum-secure communication lines between major cities like Beijing and Shanghai, China is already operationalizing quantum technologies in ways that hint at future dominance. Private industry is also racing ahead. Companies like IBM, Google, and Honeywell in the West, and Alibaba and Baidu in the East, are all building scalable quantum systems and cloud-based quantum platforms. These firms are often the first to roll out real-world use cases: drug discovery, financial modeling, materials design. But national governments are increasingly looking to them as strategic partners in the quantum arms race. In a world where military innovation increasingly relies on commercial breakthroughs, quantum supremacy may depend just as much on Silicon Valley as it does on defense contractors. But while these powerhouses sprint ahead, a quiet revolution is also taking place: the emergence of quantum startups. Across the globe, small, agile companies are developing niche solutions: quantum sensors for submarines, satellite-based quantum key distribution, and quantum-secure blockchain technologies. These innovations could be leveraged by nations to close capability gaps, or even leapfrog established players. The quantum battlefield is becoming as asymmetric as the technology itself. And yet, for all the hype and investment, many experts caution against overconfidence. Quantum computing is still in its infancy. Qubits are notoriously fragile, and building systems with error correction, stability, and scalability is a massive technical challenge. As of now, no quantum computer has cracked RSA encryption at the scale used for real-world security. But the field is advancing rapidly, and the gap between possibility and practice is narrowing every year. This brings us to a pivotal moment in History 1, where countries must prepare not just for what quantum computers can do now, but for what they'll be capable of soon. This means developing quantum-literate defense forces, modernizing digital infrastructure to adopt quantum-safe encryption, and investing in long-term strategic resilience. It also means having frank discussions about the ethics and governance of such a powerful tool. Just like nuclear weapons in the 20th century, quantum technology will require treaties, norms, and diplomacy to prevent misuse and maintain stability. So what does this mean for the average citizen? It means the digital future you rely on, from your health records, to your online banking, to your country's defense systems, soon be operating under a completely different set of rules. The safeguards we've trusted for decades could become irrelevant unless replaced by next-generation protections. The passwords, encryption keys, and firewalls that make you feel safe today are only as strong as the technology backing them. And quantum computing has the potential to blow that foundation wide open. But it also opens the door to immense opportunity, harnessed ethically and collaboratively. Quantum technology could lead to unprecedented medical discoveries, environmental solutions, and innovations in space travel and clean energy. The same machines that could destroy our current systems could also help us build better ones. If we act wisely, as we stand on the edge of this quantum frontier. The question isn't whether quantum computing will change the world. The question is, will we be ready when it does? Will we use this incredible power to create a safer, more secure, and more innovative future? Or will we stumble into a new digital arms race where control, secrecy, and fear dictate the rules? That decision starts now with policymakers, scientists, educators, everyday citizens, all playing a role in shaping how we handle the most transformative technology of the 21st century. So, the next time you hear the term quantum computing, don't just think of physics or math. Think of your privacy, your country's security, and the choices we make today that will define tomorrow's world. Because the quantum revolution isn't coming. It's already here.